Good morning, students. Welcome to the class again. We were discussing mass spectrometry. I have just given the formula for calculating the relative intensity of M plus 1 peak and relative intensity of M plus 2 peak. You can concentrate on relative intensity of M plus 1 peak. It is given by number of carbons multiplied by relative intensity of carbon isotope, that is carbon 13, 1.1%. Similarly, plus number of hydrogens multiplied by relative intensity of hydrogen 2, relative abundance, that is 0.016. Similarly, for nitrogens, for sulfur, for silicon. Now, how do we utilize this data to identify the number of carbons in a molecule or to identify the formula of the compound? If you want to identify the formula, then when you know the M peak, you know the mass. So accordingly, take some carbons and hydrogens and nitrogens. Calculate the M plus 1 peak intensity. If it matches with the given M plus 1 peak intensity, then that is the molecular formula. Now, for CSIR exam, it is even simpler. The mass spectrum of an unknown compound has a molecular ion peak with a relative intensity of 43%. So the M plus ion peak is 43.27% and M plus 1 ion peak with a relative intensity of 3.81%. How many carbons are there? So it is a very simple problem. So that means in the calculation of M plus 1 peak intensity, we need to ignore all other contributions, number of carbons multiplied by 1.1. So just take this one. Just ignore all other. Just ignore all other. For example, if you have M plus peak whose intensity is 100%, then we can go for the ratio, right? M peak intensity by M plus 1 peak intensity, ratio of M peak intensity by M plus 1 peak intensities, that is 100% by number of carbons into 1.1%. 100% by 1.1%. So both are percentages, just leave it. For example, 1.1, nothing but 1. So we can ignore this one, right? Yeah, when we ignore this, it gives a meaningful information, or it gives a shortcut to identify the number of carbons. See, you just take the ratio, then rearrange this equation, you will get number of carbons, right? So this is an important formula for CSIR and GATE exams. The ratio of intensity of M peak by M plus 1 peak is equal to 100 by number of carbons, right? Coming to this problem, what is this? M peak intensity is 43.27%, M plus 1 peak intensity is 3.81%. So percentages, both percentages will get cancelled, not a problem. Then number of carbons, here also the percentage by percentage, so that will get cancelled. What we will get only number of carbons, or we can rearrange it. Number of carbons is equal to 100 into 3.81 divided by 43, right? You can solve this, right? So I don't need to solve this problem. So in this fashion, we can easily calculate the number of carbons. At the same time, we can calculate the number of hydrogens, nitrogens, then we can go for the molecular formula. Then, of course, it is a theory bit, it is not a competitive exam. Now, how do the competitive exams, they will ask this question? Yes, I'll give you quickly two problems, right? Remember this formula. You must remember this formula. Yes, acetone and acetone D6 may be readily distinguished by, right? When you have isotopes, of course, you can identify them using IR because isotopics will give different frequencies. But in this, it was not there. Option was not there. Then we can also identify isotopes using mass spectrometry, because isotopes will change their mass. So if mass is changed by 1, we can identify that, because we have 6 deuteriums. Acetone mass and acetone D6 mass will be varied by 6 units. So we can identify it. Okay, it's not a problem. Right. Now look at this problem. In the mass spectrum of dodecahedron, dodeca 20, approximate ratio of the peaks at M by Z 260 and 261 is. Approximate ratio of peaks at M by Z 260 and 261 is. What is 260? We have 20 carbons, 20 into 12. Right, let me calculate this. Yes, we have 20 carbons, so 20 into 12, 240, 20 hydrogens, 260. So 260 is nothing but M peak. What is 261? It is M plus 1 peak, isotopes. So what he is asking for, the approximate ratio of the peaks at M by Z 260 and 261 is. That means he is asking for the ratio of intensities of M and M plus 1 peak intensities. M and M plus 1 peak intensities. What is the formula? The ratio of M and M plus 1 peak intensities is equal to 100 by number of carbons. 100 by number of carbons. That's it. 100 by number of carbons. So here it is dodecahedron. So 100 by 20. It is nothing but 10 by 2, nothing but 5 by 1, or 5 is to 1. See how simple it is. So if you are asked to find out the ratio of M by M plus 1 peak intensities, it is a very simple problem. Just take this formula, 100 by number of carbons. So if you know the number of carbons in the compound, you can easily identify the ratio M by M plus 1 peak. For example, look at this problem. The ratio of M and M plus 1 peaks in the mass spectrum of C60 is. What is C6? Number of carbons were given. So M by M plus 1 peak intensity is equal to 100 by 60. So it is 3 by 2. It is 5 by 3. Right? 5 by 3. 5 by 3 is not given, right? So 5 by 3 is not given, then go for further simplification. For example, you can go for this 3 is to 2. Okay. For example, if it is 33%, 100, 33, and 33 into 2, it is 67, something like this, but you can go for this. Okay. Strictly speaking, it is 5 by 3, but it is not given. Then other option is divide it with 33. 3300 we can go for 3 times. 60 we can go for 2 times. 33 into 2, 66. Of course, relatively similar. So in this fashion, if you are given this question, hardly it takes less than 2 seconds. Right? I'll give you one more problem. You practice this. In the mass spectrum of decane means C10H22. The ratio of peaks at M by Z 142 and 143 is. Now first calculate what is 142 and 143. So just take the 10 into carbon 12 plus 22 into 1. If you are getting 142, it is M peak. It will be M plus 1 peak. Then go for this ratio. So always remember this formula, ratio of M by M plus 1 peak intensities is equal to 100 by number of carbons. Now we will discuss about the next important concept. For this, we need to remember these values: chlorine and bromine. Chlorine 35 isotope is 100% available, whereas chlorine 37 isotope is 33% available. Bromine 79 isotope is 100% available. Bromine 81 is also 100% available. Bromine is 1:1. Chlorine is 3:1. Okay, chlorine is 3:1. Okay, I'm sorry, in this chlorine is 3:1, right? So you need to go for this 35 plus 35 plus 35 plus 37 by 4. Okay, because chlorine is 3:1. Okay, then how do we utilize this data for answering one more question in a CSIR gate? This data can be utilized to identify the number of halogens, either chlorines or bromines, present in a molecule by looking at the m plus 2 or m plus 2, m plus 4 or m plus 2, m plus 4, m plus 6 peak intensities. Chlorine isotopes, they differ by 2, bromine isotopes, they differ by 2. So we can utilize this data and we can easily identify the number of halogens present in the molecule by looking at the m plus 2 peak intensities, ratio of intensities, or m plus 2, m plus 4, or something like this. Now, you please remember these values. If you have one bromine in the molecule, then the m and m plus 2 peaks will appear with 1:1 ratio. Of course, bromine 2 isotopes are available 100% and 98%. That means 1:1 ratio. So if you have one bromine in the molecule, the m and m plus 2 peaks, they will appear with 1:1 ratio. Similarly, if we have two bromines in the molecule, two bromine atoms in the molecule, it will get three peaks, m plus 2, m plus 4, with a ratio of 1:2:1, with a ratio of 1:2:1. If we have three bromine atoms in the molecule, then we will get four peaks, m plus 2, m plus 4, and m plus 6, with a ratio of 1:3:3:1, with a ratio of 1:3:3:1. So if you have one bromine, two peaks, 1:1. If you have two bromines, 1:2:1, three peaks. If you have three bromines, four peaks, with 1:3:3:1. Okay. Now, similarly, when we have one chlorine, because chlorine isotopes are 3:1 ratio, so the two peaks, m and m plus 2 peaks, will have a ratio of intensity ratio of 3:1. If we have two chlorines, we will get three peaks, m plus 2, m plus 4, in the ratio of 9:6:1. If we have three chlorine atoms in the molecule, we will get four peaks, m plus 2, m plus 4, m plus 6, in the ratio of 29:28:9:1. 29:28:9:1, or simply you can go for 3:3:1:0.1. 3:3:1:0.1. So if you have one chlorine, we will get two peaks, m and m plus 2, with an intensity ratio of 3:1. If we have two chlorines, we will get three peaks with an intensity ratio of 9:6:1. If we have three chlorines, we will get four peaks with an intensity ratio of 29:28:9:1, or simplified is 3:3:1:0.1. If we have one bromine and one chlorine, then we will get three peaks with an intensity ratio of 3:4:1. One bromine and one chlorine, 3:4:1. If we have one chlorine and two bromines, we will get four peaks, m plus 2, m plus 4, m plus 6. So the intensity ratios are 3:7:5:1. There is no other option. You need to by heart this. If you have one chlorine and two bromines, the four peaks, 3:7:5:1. If you have 2 chlorines and 1 bromine, the 4 peaks will appear in 10:16:7:1. So 1 bromine, 1 chlorine, 3:4:1. 1 chlorine, 2 bromines, 3:7:5:1. 2 chlorines, 1 bromine, 10:16:7:1. You need to by heart this. Now, how do we utilize this data for answering CSI questions? Right. We will look at some examples. The mass spectrum of the compound A formed in the following. I'll give all this material. A formed in the following reaction exhibits M plus 2, M plus 4 peaks in the ratio of about 1:2:1. The reagent HX and the product A are. See, when you look at the ratio 1:2:1, you must identify that it is because of the presence of 2 bromine atoms. So, in the compound A, we will have 2 bromine atoms. Yeah, this was given, 1 bromine was there. So, in the product, in this reaction, we are adding 1 more bromine. We are adding 1 more bromine. So, that is why we are getting 1:2:1 ratio of M plus 2, M plus 4 peaks. So, generally what will happen, alcohol can be converted into halogen by treating with hydro. For example, if you want to convert this into chlorine, we need to use HCl. If you want to convert this into bromine, we need to use HBr. If we want to convert this alcohol into fluorine, we need to use HF. So because of this ratio, we understood that there were 2 bromines. So that means the HX should be HBr. And among the 2 products, of course, you know, it will be this one only. Okay. Because initially protonation takes place here. Dehydration leads to benzyl carbocation. Benzyl carbocation is more stable, then Br minus will approach this benzyl carbocation. So it is the product. So from the ratio of M plus 2, M plus 4, M plus 6 data, we can identify the molecules. I'll give you one more example. Bromine has 2 common isotopes, bromine 79 and bromine 81, that occur in the ratio of 1:1. What would one expect to find in the mass spectrum of bromobenzene? What would one expect in the mass spectrum of bromobenzene? First, we will look at the bromobenzene. This is bromobenzene. Its mass is 80. It is C6H5, nothing but 77. Okay, so up to this it is 77, or completely it is 80 plus 77, 157. So total mass is 157. Up to phenyl ring it is 77. Now what is the answers? Now we will look at the answers. A large peak at a M by Z value of 78, a large peak at a M by Z value of 77 and only one molecular ion peak, a large peak at a M by Z value of 77 and 2 molecular ion peaks of different intensities, a large peak at a M by Z value of 77 and 2 molecular ion peaks of same intensities. When we know there is the presence of bromine atom, we know there exists 2 peaks, M and M plus 2, with same intensity, 1:1. Right? So yeah, 157 peak will be 1:1. When it undergoes fragmentation, bromine and phenyl ring, they will undergo fragmentation. So it generates phenyl carbocation whose mass is 77. Whose mass is 77. So a large peak, it is the most stable peak. So it forms the base peak. So a large peak at M by Z value of 77 and 2 molecular ion peaks of same intensity. Same intensity because it is the bromine atom. Now you look at this example. In the mass spectrum of CH2Cl2, the ratio of peaks at mass values 84, 86 and 88 will respectively be. you can calculate the mass, right? CH2Cl2, it will be 84. So M peak will be 84, M plus 2 86, M plus 4 88. Now you answer, any of you can answer this.